This is solving two-step equations. Our learning goals are I will be able to solve two-step equations and I will be able to verify my solution. So two-step equations, they're different from one-step equations because they have two operations. And remember, one-steps only have one. So consider the equation 5x plus 32 equals 52. What are the operations in the equation? Well, first of all, we notice that the x is being multiplied by 5, and then that whole product has 32 being added to it. So if we want to get x alone, just like one step we did with one-step equations, that means that we're going to have to undo two different operations. So here's our example, 5x plus 32 equals 52. The first thing we want is we want the term that has the variable, that's this 5x, to be alone on its side of the equal sign. That means we want to move this 32 out. We want to turn it into a 0 or move it to the other side. How can we do that? How can we turn this plus 32 into a 0? The subtraction property of equality. So we are going to subtract 32 from each side of the equation. And when we do that, we end up with 5x equals 30, which becomes 5x equals 30, which I'm sorry, my big fat head is covering and I don't know how to make it stop. Two-step equations. Now we have simplified our equation to its equivalent equation, 5x equals 30. Does this look like something we know how to solve? Of course it does. It's now a one-step equation. We have 5x equals 30. X has a coefficient. So what are we going to do? We're going to divide by that number on both sides. So 5x divided by 5, 30 divided by 5. We know that 5 divided by 5 is a 1, so we can cancel them out. And we get x is equal to 6. So that is our possible solution. X is equal to 6. So let's verify that it is in fact correct. We have to take 6 and plug it in where we see the x in the original equation. So we have 5 times 6 plus 32 equals 52. And when we simplify, we get 52 equals 52, which is a true statement. So we know that x equals 6 is the correct answer. Let's look at another example. Negative 5a minus 1 equals negative 36. Excuse me. Step 1, get the variable term alone on its side of the equal sign. Okay, so our variable term is this, negative 5a. So this minus 1 is the thing that we want to eliminate. How do we do that? We use the inverse operation. So we, instead of subtracting 1, we're going to add 1 to both sides. And that becomes 5a equals negative 35. So now we have a one-step equation. Step 2 is to get rid of the coefficient of the variable. So we're going to divide both sides by that coefficient, which is negative 5. And when we do that, negative 5 divided by negative 5 becomes 1. And we end up with a is equal to 7. Step 3 is verify your possible solution. So we are going to take this 7 and put it in for a. So our original equation was negative 5a minus 1 equals negative 36. We put 7 in for a. And when we simplify, we got negative 36 is equal to negative 36, which is a true statement. So we know that a equals 7 is our solution. So now we have a process for solving two-step equations. Step 1, isolate the term with the variable on one side of the equal sign. Step 2, if the variable has a coefficient, make it into a 1. Using multiplication or division, And number 3, verify your possible solution by substituting it back into the original equation. All right, these are our practice problems. So let's look at number 1. Negative 10k plus 7 is equal to negative 83. Step 1 says get the term with the variable in it alone on its side of the equal sign. So we want to eliminate this plus 7. And how do we do that? We use the inverse operation. So we're going to subtract 7 from both sides. And we end up with negative 10k is equal to negative 90. Step 2 is get that variable alone. So we're going to divide by the coefficient so that we end up with just the k. So we're going to divide both sides by negative 10. We know that negative 10 divided by negative 10 is a 1. So that leaves just k on the left side, and we have 9 on the right. So that's our possible solution. We're going to put it back into our original equation, and we are going to simplify, and we get a true statement. So we know that our solution is correct. So k equals 9 is our solution. I did that again. All right, so second problem, which I jumped the gun on here, is n divided by 2 minus 10. So we want to get the term n divided by 2 alone. So we want to get rid of that minus 10. We want to turn it into a 0. And the way we do that is with inverse operations. So we're going to add 10 to both sides. And when we do, we end up with n divided by 2 is equal to 9. So that was the first step. The second step says, get that n alone. Well, this is being divided by 2. The way we get rid of that is we use the inverse operation of multiplication, and we multiply both sides by 2. So you multiply both sides by the denominator that you want to eliminate. 2 divided by 2 is a 1, so we end up with an n on the left side and 18 on the right, and that's our possible solution. What do we do now? We verify it. Verifying is part of doing the work. Answers without verification are incomplete. So we put the 18 back in for the n, and we simplify, and we end up with a true statement. So we know that n equals 18 is our solution. Our third problem here, don't let the fact that the second term is the term with the variable. So we want to get rid of this negative 8. How do we get rid of negative 8? We add positive 8 to both sides, right? And then we are left with negative 10p is equal to negative 160. We want the p by itself, so we're going to divide by its coefficient. So we're dividing both sides by negative 10. We know that negative 10 divided by negative 10 is 1, so we're left with p is equal to 16. And then we are going to plug it back into our original equation, and you can just barely see above my big fat head that we have a true statement. So p equals 16 is correct. All right, we have 3 more problems. I guess we don't have any more problems. I guess there's only 3. So I guess that's it. All right, nope, there are 3 more problems. So problem number 4 is 4 is equal to negative 4n minus 8. Don't let the fact that the variable is on the right side confuse you. It's the same process. We want to get that variable term alone. So we need to get rid of this minus 8. So we use inverse operations, and we add 8 to both sides. So we have 12 is equal to negative 4n. So now step 2, eliminate the coefficient. So we're going to divide both sides by that coefficient, which is negative 4. We know that negative 4 divided by negative 4 is 1, so we end up with negative 3 is equal to n. So n is equal to negative 3. We plug that back into our equation. We simplify, and we get a true statement. So we know that n equals -3 is our solution. Problem 5. 8 plus n divided by 4 is equal to 10. Same thing. First step, get the term with the variable alone. So we have positive 8, so we want to subtract 8. So we're going to subtract 8 from both sides, and we end up with n divided by 4 is equal to 2. Now we have this n being divided by 4. How we get rid of that 4 is we multiply both sides by that denominator. So we're going to multiply both sides by 4. So we end up with 4 divided by 4 is 1. We end up with n is equal to 8. We plug that back into our original equation. We simplify, we get a true statement. So we know n equals 8 is correct. All right, last example. -55 is equal to 5 minus 6x. Step 1 says, get that variable term alone. So we want to get that 5 out of there. So how are we going to turn it into a 0? We're going to subtract 5 from both sides. And when we do, we get -60 is equal to -6x. Step 2 says get that variable alone. So we have a coefficient of -6. So we're going to divide both sides by -6. -6 divided by -6 is 1. So we end up with x is equal to 10. We plug that back in. We get a true statement. So we know that our solution is correct. X is equal to 10. And that is the video. Thank you.